All right. So Trigs has to do with your trigonometry question. In the first part of the paper, like in the section one, it will be based on basic trig ratios, SOHCAHTOA, that kind of thing, Pythagoras' theorem, etc. In section two, question 9, part of the question is sometimes circle theorems, and then the next part is on triangles. So most times you're going to have to use sine rule, cosine rule, and bearings to answer that question. So today, before we begin anything, let's just do a quick brainstorm on what you know about trigs. So tell me, what are the three trigonometric ratios? The three ratios, what are they?
SOHCAHTOA.
All right, it's SOHCAHTOA. And what does that stand for?
Uh,
So,
Sine over hypotenuse, cosine adjacent. No,
so
cosine over hypotenuse and then
no,
tangent
no, no, no,
over
wait,
adjacent.
wait. So is your sine ratio, and the sine of an angle, theta, is the opposite over the hypotenuse. So,
Oh yeah, yeah,
that
yeah, yeah.
the O stands for opposite, right? And then the A is adjacent and the H is hypotenuse. So the C in ka is really cosine, and we abbreviate it as cos. So the cos of an angle theta is equal to the adjacent over the hypotenuse. And then the last one that you said there is your tangent. So tan of theta, the ratio of the sides that gives you the tan of an angle, will be the opposite over the adjacent. All right. Now, with trigs, I would say, one of the most important things is being able to correctly identify the sides in the right angle triangle. Because as you know, the SOHCAHTOA, the trig ratios are specifically for right angle triangles. They're not used for regular triangles. It's used for right angle triangles, right? So if you have a right angle triangle, let's say this is my right angle triangle here, uh, right? And um, right, so let's say this is A, B, C, right? So this is triangle ABC. The side opposite A will be small a. The side opposite B, angle B, is small b, and then the side opposite angle C is small c. Who can tell me which side is the hypotenuse? A, B, or C?
C.
Which
C,
C?
miss.
Yes, correct. C is the hypotenuse, right? What side is right? So the right in any right angle triangle, the side that is opposite to the right angle is the hypotenuse. And you name the other sides in the right angle triangle based on where you have the angle of interest. So if I have the angle of interest, let's say theta is here, right? The side opposite that angle will be your opposite side. And the side, well, then it's only one side left, right? So that has to be your adjacent side. So with labeling the sides of your triangle, I would say the hypotenuse is obviously the easier one, well, the easiest, sorry, one to identify because it's always going to be opposite the right angle. In any right angle triangle, the hypotenuse is opposite the right angle. However, with the respect to the other two sides, that is named in reference to your angle of interest, right? So like in the triangle ABC there, the angle of interest is at A. So the side opposite that angle is your opposite side. Now I'm going to draw another triangle and I'm going to put the opposite side, sorry, the angle of interest at the other end of the triangle, right? So let's say this is A, B, C. Well, this will be side A here, this will be side C, and this side will be B. So you use the common letters to represent the sides, and you use capital letters to represent the angles. So, of course, the hypotenuse is side A in this case, because it's opposite the right angle. So this is your hypotenuse, and it's always gonna be opposite the right angle. The hypotenuse is not named according to any other angle other than the right angle, right? But in this one, if I were to put my angle of reference up here instead, so theta, my angle of reference is at B, then the side opposite that will be my opposite side. And then the third side will just be my adjacent side, right? So that's how you name the sides in your right angle triangle. And it is important to be able to do that, because if you label the triangle incorrectly, you're going to end up using the wrong ratio. And then everything is just going to go haywire, right? So SOHCAHTOA has to do with the right angle triangles. The different ratios are given to you in your list of formulae, but you have to know how to label your sides, right? I think that is also given to you because they give you like a reference triangle. So that's why I'm using it like this with the letters, because in your list of formulae, that's how it's written, right? So the next thing is, so that's your trigs. So like, for example, you can use trigs to find unknown sides and unknown angles in a right angle triangle. So let's say I have this triangle here, and let's say I want to find an unknown angle. So it's a right angle triangle, right? Suppose this side is 15 centimeters, and this side is 12 centimeters, and this angle here is 30 degrees. Sorry, let's find an unknown side first, right? I can find this unknown side here, right? Now, because this is a right angle triangle, I can also use Pythagoras' theorem, right? I can use Pythagoras' theorem to find this unknown side. Can anybody recall what Pythagoras' theorem is? Pythagoras' theorem.
E squared plus B squared equals C squared.
A squared plus B squared is equal to C squared. Yeah. So A squared plus B squared is C squared. So when you say A squared plus B squared is equal to C squared, Zach, what does that C squared represent? Which side of the triangle does that represent?
The opposite.
No, actually it represents the hypotenuse, right? So if here is
Oh,
C,
yeah.
right? Good. So then this will be C, this is A, and this is B, right? And Pythagoras' theorem tells us that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So in this triangle, let's say I want to find out what side B is. Well, I will rearrange Pythagoras' theorem to make B the subject. So instead, I'll move A squared, I'll minus it from both sides. So B squared will therefore be C squared minus B squared, minus A squared, and that will give me B squared, right? So then I just substitute my values in there. B squared will be equal to 12 squared plus 15 squared. So that would give me 12 squared plus 15 squared on your calculators. That would give you 369. And if B squared is 369, then B would be the square root of 369, right? Which is 19.2 to one decimal place. So B will be 19.2 to one decimal place, right? So whenever you have two sides, you could find a third side in a right angle triangle by simply using Pythagoras' theorem. Now, if I only had one side in that triangle, so let's say I just had, so the same triangle, right? I'm going to use the same triangle. All right, and let's say the side is 15 centimeters. This is the right angle and it's 30 degrees. And I want to find this side, right? So using Trigs, I can find that side by first labeling my sides. So in this triangle, 15 cm, we already know that 15 cm is the hypotenuse, right? So this is the hypotenuse here. And my angle of interest is over here. So that means the side B is my opposite side. So using Trigs, which ratio uses hypotenuse and opposite? Which of the ratios, guys? You have SOHCAHTOA. Yeah. SOHCAHTOA, right? So uses the opposites and the hypotenuse. So using sine theta is equal to opposite over hypotenuse, I will substitute the values now into the formula. So sine theta, my angle of interest, in this case, is 30 degrees. So sine of 30 is equal to the opposite side, which is B, over the hypotenuse, which is 15. So therefore, B would be equal to 15 times sine of 30. And you type that in directly on your calculator, 15 sine 30, and you'll get the answer. So B is
You got
15 sine
7.5,
30.
miss.
Yeah, so then let's see. I have an error somewhere then. 7.5 cm. So let's go back here and see what the error is. Aha. You know what my error was? How come nobody stopped me? B squared is C squared minus A squared. And I put C squared plus A squared. So B squared is C squared minus A squared. So C squared is 15. So 15 squared minus 12 squared, which would be 15 squared minus 12 squared is 81. So then B is the square root of, well, I'm still not getting the answer. It should be the same answer because it's the same side, it's the same triangle. Opposite, hypotenuse, opposite, right? C squared is 15. So 15 squared is 225 minus 12 squared, which is 81. So then the square root of 81 is 9. So B here is 9 cm. That's correct. Let me see what's going on here. So sine theta is the opposite over the hypotenuse. So that would be B over 15. And then B would be 15 times sine of 30, which is 7.5. I have no clue why it's giving you a different answer there, but both of these calculations are correct. Okay. So to find your unknown side, using Trigs, you will make sure that you label your sides correctly, first of all, so that you choose the correct ratio, right? Now you can also find an unknown angle using Trigs. So let's say we had two sides here, 12 cm, and let's say this side is 9 cm, right? And I want to find out this angle theta over here. First things first, you have to label your sides. So labeling my sides, the sides that are given here, yeah, remember you have to use your angle of reference to identify the sides, right? So guys, which side here is the opposite and which side is the adjacent? Because I already know that this side here is the hypotenuse. I don't need help for that. But which side in this second triangle is the opposite side and which side is your adjacent side? I'm going to ask somebody, Eliana, in this triangle, which is your opposite and which is your adjacent?
9 cm is the opposite and 12 cm is the adjacent.
Perfect. Which ratio uses the opposite and the adjacent?
4, 10.
Yes, correct. Tangent, right? So we're going to use tan of theta is equal to opposite over adjacent. And now we substitute our values in there. So tan theta is equal to the opposite, which is 9, over the adjacent, which is 12. So then theta, now this is something to make a note of. When you are finding an angle, you have to use the inverse function. So instead of, you wouldn't just say theta is tan of 9 over 12. Theta would be tan inverse of 9 over 12, which is the tan inverse of 3/4, right? So tan of 9 over tan inverse, you have to press second function on your calculator and then tan to get your tan inverse. Also, make sure that your calculator is in degrees and not radians. So the answer here, theta is equal to 36.7 degrees taken to 1 decimal place. So all of these are approximations, right? These are not direct, exact values. So you can use Trigs to find an unknown side or an unknown angle. When you are finding an unknown side, it's a simple manipulation of the formula, right? So it will be like sine over 1, and then you cross multiply here to make b the subject. B times 1 is b, 15 times sine 30 will be the other side of the equation. When you are finding an angle, you have to use the inverse function, right? Good. So for right angle triangles, guys, we use Pythagoras' theorem and we use Trigs, regular Trigs. But you will also be required to find unknown angles and sides in non-right angle triangles. Can anybody tell me which two rules you use when you are trying to find an unknown side and an unknown angle in a non-right angle triangle? Which are the two rules? Do you all know them? That you use when you are trying to find an unknown side and an unknown angle in a non-right angle triangle. There are two rules. What are they? Tristan, what are they?
Hope and
What are the
pray.
two rules?
The cosine rule and the sine rule.
We use the cosine rule and the sine rule, right? So, Tristan, do you know the cosine rule by heart?
Yeah, Mrs. A squared equals B squared plus C squared minus 2AB
No, 2BC.
or 2BC, sorry,
Yeah,
cos theta.
cos A, right? So,
Right.
the formula, by the way, is given to you in your list of formulae, but the whatever is the subject here, is the cos of the angle, the angle opposite that side. So like if it's a squared is the subject. So if you're trying to find a, then you would use a squared as the subject. So it will be a squared equal the sum of the squares of the other two sides minus 2 times the product of the other two sides by cos of the corresponding angle to that side, right? So if I'm looking at A, it's going to be cos of A, and the other two sides will be B and C. Now, if I wanted to use, if I needed to find B instead, B squared will be equal to, say down, what would B squared be equal to? What would be the difference in the formula if I wanted to find B squared? Where's Zaydan? All right. Aaron, you there? Aaron is muted.
Yeah, miss.
Equal. Okay, yes, Aaron. How would I manipulate the formula to make B squared the subject instead? What would be the changes in the formula?
A squared plus C squared
Yeah, A squared plus C squared, minus,
minus 2AC cos B.
good, thank you. Right, so again, whichever one you're trying to find, that's the cos that you're going to use. And Shaniqua, what about C squared? What if I wanted to find C? What would be the formula? Where is my girl Shaniqua? Shaniqua, you there, honey? Okay. Imani, are you there? Oh, Shaniqua, I'm hearing you now.
Yes, miss.
Yeah, if I wanted to find c squared instead, what would it be, love? Shiniko, are
B
you saying
squared
anything?
plus C squared.
Can you repeat?
B squared plus A squared.
Yeah, a squared plus b squared or b squared plus a squared, no matter the thing. Uh-huh.
Yeah.
Minus.
Minus 2AB
Mm-hmm.
cos of C.
That's right. All right, guys. So whatever is the subject, it's the same, it's the angle opposite that side, right? So the cosine rule can be used. There are two instances when the cosine rule can be used. The cosine rule can be used when you have two sides and the included angle. So two sides and the included angle. What I mean by that is if you have, like, for instance, in this triangle, if I had C and B, I had those two sides, and then the included angle will be at A, right? If it was B, then I'll need side C and side A in order to find the third side. Similarly, if it was angle C, then I would need side A and B to find side C. Okay, so you use the cosine rule if you need to find a third side given two sides and the included angle. And then the other time that you use the cosine rule is if you need to find an unknown angle and all three sides are given. Right? So those are the two instances when you can use the cosine rule to find an unknown angle an unknown side given two sides and the included angle, and then or to find an unknown angle given three sides. So let's look at a quick example, and I'm actually going to pull an example from a past paper. Yeah. So let's say, wait, I can't copy and paste onto this whiteboard, so I'll have to draw it. Okay. So let's say I had this triangle. Let me draw it quickly. Right. So that obviously it's a non-right angle triangle. Let's say that this angle here is 54 degrees, and the two sides, this is 100 km, and this side is 80 km. Right? And so this is an actual question. This is from 2014, right? This is June 2014. So the sides are labeled Q, R, and P. This is Q, R, and P, and we need to find the side RP. So the side RP, guys, is actually side Q, right? So I can use the cosine rule here because I have two given sides and the included angle. The angle is between the two sides, so I can go ahead and use the cosine rule. So Fired, are you there? Where is Fired? Right. Imani, are you there?
Yes, miss.
Can you help me with this one to find Q, side Q, using the
Okay.
cosine rule? Yeah. So first, let's write over the formula with the letters, right? So it will be Q squared is equal to what? Q squared is equal to. Do you need to look back at the formula?
No, miss. Is it B squared plus C squared?
Well, it will be, in this case, it'll be R squared because it's R and P here, right? Because this triangle is PQR. So Q squared will be equal to R squared plus P squared minus what?
Q squared?
No, minus 2RP cos of Q, right? Because we're using the cosine rule of. So the cosine rule would be, and don't worry if you don't know it by heart because this is given to you. So the cosine rule would be Q squared, because that's the side we're trying to find, equal to the sum of the squares of the other two sides. So R squared plus P squared minus 2 times R times P times cos of Q, right? R and P would be R is the side opposite angle R, so that's 80 km, and P is the side opposite angle P, which is 100 km. And now we're going to substitute our values in there, okay? So Q squared is just going to remain like that because I don't know what it is. I'm trying to find it. Right, so R squared. So tell me the substitution then, Imani. I'm substituting the values into the formula. So tell me what to write. R is which side? Oh, I lost Imani. R squared. Somebody else. Evan. Evan, where are you? You there, Evan?
Yeah, miss. R squared is
Evan.
80 kilometers.
Right. So R squared will be 80 squared plus P squared. What's P?
100 squared.
Mm-hmm. Minus 2 by
2 by 100. 2
mm-hmm.
by 80 by 100.
Yes. Cos of.
Cos of 54.
That's right. Perfect. So Q squared will be 80 squared plus 100 squared minus 2 times 80 times 100 cos of 54. So this is because R is 80, so R squared will be 80 squared. P is 100, so P squared will be 100 squared. And then 2RP means 2 times R times P. So now we could work this out. You can do two things. You can either like work it out individually. So you could do 80 squared plus 100 squared, which will give me 6,005. No, sorry. 100. 1,000. 16,000, sorry, 400 minus 2 times 80 times 100, which is 16,000. By cos of 54 degrees, right? And then that would give me, so you could type this in directly. Now, you could have actually, from the very beginning, from here, right? You could type this whole thing into your calculator. So we'll do it like that afterwards. And make sure you have your calculator so you know what you're doing, please. So this is 16,400 minus 16,000 by cos of 54, which will give you this number, 6995.4359, and so on, right? So if Q squared is that, then Q will be the square root of that. So the square root of 6995.4359. The reason I'm putting dots is because I'm leaving it on my calculator and then I'm just going to press square root, which gives me 83.6 km to 1 decimal place. All right. So you could have also typed this in directly on your calculator. So you could have done 80 squared plus 100 squared minus 2 brackets 80, close brackets, open brackets again, 100, close brackets, cos of 54. And you will get this, you'll go straight from here to this. And then you press square root and equal, and you'll go straight from that to this, right? So you can do it like that as well. So that's how we will use the cosine rule to find an unknown side. Hope this rings a bell, guys. If it doesn't, please let me know, and I will direct you to the class recording that we did on cosine rule. We've done this twice before. So this is the third time we're actually doing it, right? Well, for those of you who've been with me since. Right. The other time, so you can use the cosine rule to find unknown side when you have two sides and the included angle. And you can also use the cosine rule to find a third side, an unknown angle when you have all three sides. So let's look at it as an example like that. Right? So let's say I have this triangle and let me take a browse quickly and see if I have any of them with all three sides so that I can use the cosine. I don't think I do. So what I'll do is I'll just make it up. All right, so let's say I have this triangle. This is triangle A. This is triangle A, B, C. Let's say this side is 20 cm. This side is 30 cm. And this side is 60 cm. Right? And I want to find angle A. So I want to find angle A. Now, if I want to find angle A, first thing, I'm going to just label these sides. So the side opposite angle A is side A. The side opposite angle C is side C. And the side opposite angle B is side B. So if I want to find angle A, I need to recall the cosine rule that has A as the subject. So that is A squared is equal to B squared plus C squared minus 2 times B times C by cos of A. Right? And now I need to substitute my values into the formula to make cos of A the subject because I want to find angle A. So substituting my values, A squared, A here is 60, so A squared will be 60 squared. B squared, B is 30, so B squared is 30 squared. C squared, C is 20, so C squared is 20 squared, minus 2 times B, which is 30, by C, which is 20, by cos of A. Oh, I'm running out of space. 1 second. Yeah, by cos of A. Right? And now I could simplify this. So simplifying, 60 squared is 3,600, I believe. 60 squared, yes. 3,600 is equal to 30 squared plus 20 squared. I'm working that out directly on my calculator. That would give me 1,300 minus 2 times 30 times 60. Sorry, 2 times 30 times 20. That's 1,200 by cos of A. Now, let me tell you all, I want you all to be very careful here. Let me show you an error that students make. Students make this error all the time. From here, what I've seen students doing is they'll keep 3,600 here, and they'll say 1,300 take away 1,200, which will be 100 cos of A. This is wrong. Okay, that is not how you simplify this part because this 1,200 is not by itself. It's not a constant. This is 1,200 times cos of A. So you cannot subtract 1,200 from 1,300, right? That's the primary mistake that students make. That's like if I had 5 take away 2x, and then I say this is 5 take away 2x is 3x. That's wrong. Right? Because 5 is a constant and 2x is a variable where the coefficient is 2. So 5 minus 2x is as simple as it can get. You cannot do anything with that. In the same way, 1,300 minus 1,200 times cos A, you cannot minus the 1,200 there. The 1,200 is part of cos A. But what you can do at this point is you can minus 1,300 from 3,600 because these are both constants. So at this point, you would say 3,600 take away 1,300, right? So you'll move the 1,300 to the other side of the equation. So you'll now end up with 1,300 minus 1,300. 3,600 minus 1,300 is minus 1,200 by cos of A. And now you can simplify, right? So 3,600 take away 1,300 is 23. So this here will be 2,300. So 2,300 is equal to negative 1200 by cos of A. Okay, so then cos of A will be, well, if it's minus 1200, multiply by cos of A, dividing throughout by minus 1200, we'll get rid of the coefficient here. So this will be 2300 over minus 1200 is cos of A, right? So 2300 divided by negative 1200 is a long number. It's negative 1.9166, and I'm going to put these dots. So that is equal to cos of A. And just like when we were finding the angle using regular Trigs, how you had to use the inverse function, you have to use the inverse function with the cosine rule as well, because you're finding an angle. So therefore, A would be equal to the cos inverse of negative 1.91666, whatever. All right, so on your calculators, you should still have this on your screen. Then you press second function, cos, to get cos inverse. You'll have to do it over, right? So let's see. So this will be second function cos inverse of negative 1.9166. Okay, so I'm getting an error, so it means I have a mistake somewhere. Let's see what the mistake could be. Checking it over. So 60 squared, A is 60 squared, A squared is 60 squared, B squared is 30 squared, C squared is 20 squared, minus 2 times 30 times 20, that's cos A. So 60 squared is equal to 3,600. 30 squared plus 20 squared is 1,300, right? And then 2 times 20 times 30 is 1,200. Okay, so far so good. So then we'll say 3,600 take away 1,300, which will give me 2,300. So then cos A will be 2,300 divided by negative 1,200. Yeah, which is negative 1.9166. So then cos inverse of that is an error. So something is wrong, maybe with the numbers themselves, but not with the calculation. The calculation is still correct. So this would have been, if you did 1,300, take away 3,600. And then you find cos inverse of that. Okay, yeah. So anyway, these are the steps, guys. These are the exact steps here. I made up this question, so I could have very well just made a mistake with the numbers themselves. But these are the correct steps. And that's what is most important here, that you have the correct steps, right? So firstly, you label your sides. And if you're finding angle A, you have to use the cos rule that starts with the A. So it'll be A squared equals the sum of the squares of the other two sides. So B squared plus C squared minus 2 times the product of those two other sides by cos of the angle. So 60 squared is equal to 30 squared plus 20 squared minus 2 times 30 times 20 by cos of A. And then you simplify this. So 60 squared is 3,600, 30 squared plus 20 squared. So that'll be 900 plus 400, which is 1,300, minus 2 times 30 times 20. So 30 times 20 is 600, and 600 times 2 is 1,200. So that's how I got this. And then here, like I said, I want you all to be very careful with it, because this is where students make a mistake, this part here, right? You cannot take away minus, you cannot do 1,300 minus 1,200. You have to, it still is algebra. So you still can only add and subtract like terms. Because this is 1,200 times cos A, this makes this one term. So this is by itself. So you'll have 1,300 minus 1,200 cos A. You'd have to minus 1,300 from this side. Okay, so it's your conventional rules of algebra. All right. So the reason that we have an error here is because you cannot actually take the cos of a negative number, right? So something I made a mistake with probably the choice of values that I put here. So that's the cosine rule. What about the sine rule? Who can recall the sine rule for me? What is the sine rule? Zach, remember the sine rule?
I'm not too sure.
All right. Anybody knows what the sine rule is?
Which is that the one where it's like A plus or minus B or something?
Nah.
All right, then I don't know that.
All right. Who knows the sine
Is
rule?
is
Somebody.
is A over sine A equals B over sine B?
Yes. A over sine A is equal to B over sine B, which is equal to C over sine C, right? So the sine rule, which is also used for non-right angle triangles, help us to find we use it to find the unknown sides or unknown angles in non-right angle triangles. So the sine rule is A, side A, over the sine of angle A equals side B over the sine of angle B is equal to C over sine of angle C. And you don't use all three of them when you're solving a question. You really only use two of them. So A over sine A is equal to B over sine B is equal to C over sine C. Just means these ratios are all equal to each other. And what is important is that side A is opposite angle A, right? So that's how you apply the rule. So A over sine A is equal to B over sine B is equal to C over sine C. And the two times that you use the sine rule, the first time is when if you need to find a side and you have any two sides and any angle and any two sides. So to find a side when you're given an angle and any two sides, an angle and any two sides to find one side, right? So, this would be if you're finding an angle, sorry. So this is to find an angle. So you're given one angle and any two sides, right? So I should literally write that. I should write to find a missing angle, to find an angle, another angle, right? Or you can use it to find an unknown side when you have two angles and any side, right? So with the cosine rule, let's go back. With the cosine rule, you use the cosine rule to find an unknown side when given two sides and the included angle, right? Two sides and it has to be the included angle, right? Or to find an angle when you're given you're given all three sides. So to find an angle when you are given all three sides, okay? So for example, with the cosine rule, it was like, here, I wanted to find this unknown side. I had two sides and the included angle. And also in this one where I had the error, but I wanted to find an unknown angle. So I had all three sides. And that's how I was able to use the cosine rule. But the sine rule, you have to have, if you want to find an angle, you have to have one other angle and any two sides. Or if you want to find an unknown side, you need two angles and any side. Right? So it's different circumstances that you need in order to use the sine rule or the cosine. So let's look at an example with the sine rule now. All right, so say we had a triangle. Let me see if I could pull one from the past papers that I have in front of me here. Hold on. Give me 1 second. I mean, I guess I could just make up the question because, yeah, let me just make it up. Hopefully we don't run into error again. But we're going to use a sine rule to find an unknown side. So let's draw the triangle quickly. So with the sine rule, unlike the cosine rule, it doesn't have to be the included angle. It could be a different angle, right? So let's say I had, let's say this angle here is 30 degrees. And this side is 4 centimeters. And this side is 6 centimeters. And I want to find this angle marked X. Okay? So I want to find this angle marked X. I have these two sides, 6 and 4, and I have this angle of 30 degrees. So the sine rule, if you want, you could label your triangle A, B, C, right? So then if this is A, side A will be here. If this is angle C, this would be side C, and then side B would be here. And I want to find angle C. So the question is to find angle C. All right. So I recall that the rule is the side over the sine of the corresponding angle is equal to the side over the corresponding angle. So if I'm looking at C, that would mean that C over sine of C is equal to A over sine of A. I'm using these because that's what I'm given, right? I have angle A and I have side A, and I have side C. I'm trying to find angle C. So at this point, I'm going to substitute my values into the formula. So C is 6 centimeters. Sine of C would be sine of C, because we're trying to find that, is equal to A, which is 4 centimeters, over the sine of angle A, which is 30 degrees. And now I cross multiply. So 4 times sine C is equal to 6 times sine of 30. All right. And therefore, sine of C is equal to 6 times sine of 30 divided by 4. So you could put that in your calculator. 6 sine 30 divided by 4, which will give you 0.75. So therefore, sine of C is equal to 0.75. Now remember, whenever you're finding an angle, you have to use the inverse function. So C would be equal to sine inverse of 0.75. So you do second function sine, and this will give you C will be equal to 48.6 degrees taken to 1 decimal place. So unlike the cosine rule, where you needed to have all 3 sides in order to find an angle, in the sine rule, you simply need 2 sides and one of the angles opposite one of those known sides, and you'll be fine. Okay, so let's look at using the sine rule to find, so we just looked at it to find an unknown angle. Let's use it to find an unknown side now. So suppose I have a triangle. Okay, and let's say this angle here is 40 degrees, and this angle is, this could be 30 degrees. And let's say this side is 12 centimeters, and I want to find this side here. So label a triangle A, B, C, right? And I want to find side C. So find side C. Okay, so I recall first of all, let me label the triangle. So this side will be A, this side will be B, and well, that side is C, right? The sides are opposite. Common A is opposite angle A, common B is opposite angle B, and common C is opposite angle C. So we use common letters for the sides. Okay, so substituting our values, I'll say C over sine C is equal to B over sine B. And now I substitute my values in there. C is what I'm trying to find. Sine C is sine of 30 degrees. And that is equal to B, which is 12 centimeters over the sine of B, which is 40 degrees. And then I cross multiply. So 12 C times sine of 40. C times sine of 40 is equal to 12 times sine of 30. So therefore, C is equal to 12 sine of 30 divided by sine of 40. So there's no need to use sine inverse here because I'm trying to find a side, all right? So you don't need to do the inverse. The only time you need to do the inverse is when you are trying to find an angle. So C is therefore equal to 9.3 centimeters taken to 1 decimal place. All right, guys. So these are when you are using your cosine rule, you can only use your cosine rule when you have two sides and the included angle to find an unknown side, or when you have three sides to find an unknown angle. The sine rule, however, is used when you have an angle and any two sides to find a missing angle, or two angles on any side to find an unknown side, like we just did. So far we've looked at, and these are the things that you need to know for your trigonometry, your Trigs questions, right? You need to know your SOHCAHTOA. Now, even though the formulas are given to you in your list, you must still be able to interpret the formula and select the correct one. And in order to select the correct one, you have to name the sides of your triangle correctly. All right, so you can use SOHCAHTOA, sine, cosine, or tangent to find an unknown side or an unknown angle in a right angle triangle. It must be a right angle triangle. It cannot work for any other type of triangle. And you can also use Pythagoras' theorem to find an unknown side in a right angle triangle. Pythagoras' theorem tells us that the square of the hypotenuse is equal to the square of the other two sides. So if you had to find the hypotenuse, you simply have to add the square of the other two sides and then take the square root of it. If you, however, had to find another side in the right angle triangle, one side that is not Pythagoras' theorem, you would rearrange the formula to make that side the subject. So like if I wanted to find B, as in the case of this example, it would be the square of the hypotenuse minus the square of the other side. And if I wanted to find A, it would be the same thing, except I will minus B, right? So that is fairly simple. But Pythagoras' theorem is not given to you in your list of formulae, so you have to know it, right? And we looked at the sine rule and the cosine rule, which again is given to you. Something I forgot to mention is angles of elevation and depression. So you have to be able for CSEC to identify what is an angle of elevation and what is an angle of depression. So firstly, when we think of the word elevate, we think of up, right? Going up. So the angle of elevation, if you have a point here, so let's say this is the point P, right? And this is the point Q. The angle of elevation of Q from P will be, first of all, there are two things that are very important when you're looking at angles of elevation and angles of depression. It's the horizontal and the line of sight. So the line of sight would be the line between P and Q, the line that's joining P and Q, right? So that's this line here. The angle of elevation of Q from P will be the angle between the horizontal line drawn at P here. So this is the horizontal. This is what we call the horizontal because it's a horizontal line, right? It's at P. The angle of elevation will be the angle between the horizontal. So this is your angle of elevation. Your angle of elevation is your angle between the horizontal at P and the line of sight. So your line of sight is the line that connects the 2 points. So this is the angle of elevation of Q from P. You can only take an angle of elevation so the angle of elevation has to be from a point that is lower, right? So the angle of elevation of Q from P, notice that Q is higher than P. So to get from P to Q, it has to increase. So your angle of elevation is the angle formed between the horizontal drawn at P, your starting point, and your line of sight. That is your angle of elevation, okay? It has to be between the horizontal though, so don't be confused with that. And if you're looking at elevation, it's going to be at the bottom here because it's looking up. It's as if somebody is at P and they're looking up at Q, like a man on the ground looking up at an airplane, for instance. The angle of elevation will be between his eye level and the plane in the sky. Now, the angle of depression, when you think of depressing, it's down, right? Depress. Your angle of depression is down. So that's like if I'm using Q and P again. So let's say you're at Q here and P is on the ground, right? Your angle of depression of P from Q, it could only be P from Q because P is below Q. You cannot have an angle of depression of Q from P because P is below Q. All right. So the angle of depression has to be from Q to P. So the angle of depression of P from Q, you need to have your horizontal always, right? So the horizontal will be at Q. It has to be at Q because Q is above P, right? So this is your horizontal. And then your line of sight is the line that connects P and Q. So your angle of depression is going to be here. This is your angle of depression. Angle of depression of P from Q. All right. And here you have your horizontal. So your horizontal will be at Q since you're looking down at P. And your line of sight is the line that connects the 2 points. You have to be able to identify your angle of elevation and your angle of depression. It's very important that you know how to do that. All right, so your angle of elevation and your angle of depression. Angle of elevation would be the angle formed between a point lower to the point higher between the horizontal and the line of sight, as in P and Q here. The angle of depression will be the angle at the top looking down between the horizontal and the line of sight. So those are some fundamental principles, right? The next thing that you need to know is bearings. Right, so in order to do a trig question, you have to know your bearings. So the bearings that we look at for trigs, for these trig questions in CSEC, they're 3-figure bearings, right? So it's 3-figure bearings. So that means if it's a acute angle, well, if it's any angle less than 100, you would have to use 3 figures, right? So it's 3-figure bearings. So for instance, a bearing of 45 degrees would be written as 0.45, right? So you must use 3 figures for it. Now, a bearing, all right, let's say I have 2 points. I have the point A, and let's say this point here is B, right? B is on a bearing of A. Sorry, B is on a bearing of, let's say, 30 degrees from A. So if B is on a bearing of 30 degrees from A, you see the word from? From is very important when you're looking at bearings because from tells us where we need to put our north line, right? Or where the bearing is being measured. A bearing is a clockwise angle that we use, right? So if I'm looking at the bearing of B from A, my north line goes at A. So I'm going to put my north line here at A. And this, the bearing of B from A is going to be the bearing of B from A is going to be the clockwise angle. It's the clockwise angle between the north line at A and the line that connects A to B, like this. So the bearing is this clockwise angle here. This is the bearing, right? So let's say that's 35 degrees. I will write that as 035. So I will say that B is on a bearing of 035 degrees from A. If it is from A, it means that your north line is at A. It is the clockwise angle. So the bearing is always counted or calculated in a clockwise direction, right? So if you know the bearing of B from A, you can also figure out the bearing of A from B. And let me show you how. To figure out the bearing of A from B, well, if it's from B, it means I'm putting a north line at B. And I have to calculate the clockwise angle from B to A. So the clockwise angle here is going to be, you'll be starting here and going in a clockwise direction. So this angle on the outside here is the bearing of A from B. So to calculate that bearing, what you would do is we're going to use the rules of parallel lines. Parallel lines, the two north lines here are parallel to one another. And when you have two parallel lines, the interior angles here, this angle and this angle, because this is a transversal, the angles between the pair of parallel lines and the transversal adds up to 180 degrees. So therefore, this angle here will be 180 minus 35, which is 145. So this angle here is 145 degrees. And of course, you should know that the angles around a point is 360 degrees. So to find this clockwise angle here, which is the bearing of A from B, we would say 360 take away 145. And that would give me 215 degrees. So 215 degrees is the bearing of A from B. So therefore, A is on a bearing of 215 degrees from B. So once you know the bearing of one point, you can figure out the bearing of the other point. So if you know the bearing of B from A, you can figure out the bearing of A from B. So let's look at this again, because this is a point of contention for students always, right? So let's say, and I am going to call on some of you. So let's say I have M. This is my point M, and I have another point N. No, let's call this P, because M and N sound too close. Good. And let's say that P is on a bearing of, so let me draw this line from M to P first of all. So this is MP, that's the line MP, and I want to look at the bearing of P from M. So if it's from M, I'll have my north line at M, because that's the starting point, right? And the bearing of P from M will be the angle between the north line and P, the line connecting M to P. So that's this angle. That's obviously more than 90. So let's say this angle is 110 degrees. I can say that P is on a bearing. P is on a bearing of 110 degrees from M. So let's say I want to find the bearing of M from P instead. What I do is I draw a north line at P, right? So my north line will go at P because now I want to know the bearing of M from P. So whatever is the from, the starting point is where you're measuring your angle, right? So M from P, my north line is here. The clockwise angle. So the bearing of M from P is going to be your opening around here because this is your clockwise angle here, right? So M from P is this angle around here. Now, in order to find that angle, what I would say is 180 minus 110 because these two lines, these two north lines at M and P are parallel to one another. And if they are parallel and this line MP is the transversal, these interior angles add up to 180 degrees. So therefore, this angle here on the inside is 70 degrees because it'll be 180 minus 110. And so I can figure out the clockwise angle, the remaining clockwise angle around here, because the angles around this whole point will add up to 360. So you'll say 360 take away 70, which is 290 degrees. And therefore, the bearing M is on a bearing of 290 degrees from P. Right. So I'm going to call on someone to help me figure this out. Okay. Jazara, are you there?
Yes, sir.
All right, so let's do one, okay? So let's say I have this point here is A, and this point is B. And I tell you that B is on a bearing of, let's see. B is, so if we're looking at B from A, the north line will go at A here. Right, so the north line will go at A. And the bearing of B from A will be this angle around here. And let's say this angle is 275 degrees, right? So B is on a bearing, or the bearing of B from A. B is on a bearing of 275 degrees from A. Right, Jazaro? How then would I find the bearing of A from B? A from B instead.
So it'd be 360 from, 275 from 360.
The bearing of B, sorry, of A from B. No, well, remember, first we need to identify where the angle is, right? The angle, the bearing of A from B. So the bearing of A from B is not going to be this angle here. This is not the bearing of A from B. Because if you're saying from B, where does the north line go?
From B?
From B, right? So the north line has to go at B. And the bearing of A from B is the clockwise angle between that north line at B, and the line that connects in both of them. So the bearing of A from B is going to be this angle here, right? Not this one. Not this one. This has nothing to do with that. The bearing of A from B is going to be this angle, this clockwise angle between the north line at B and E. So how would I calculate this one? Now, you are correct in that to calculate this angle here, you would say 275 from 360. How much is that?
95?
95 or 85?
I mean 85.
Right. Good.
Then-
And now to find this angle, what would we do?
Wait, when's it be 85 from 180?
Correct. It would be because these two angles inside the two north lines here would be 180. The sum is 180. So it would be how much?
95?
Mm-hmm. So therefore, the bearing of A from B is 95 degrees. So you'll write 0, 9, 5 degrees. So guys, this is a confusing, students find this very confusing, right? So I really want you all, I'm going to do another one. I really want you all to understand the how you identify a bearing, right? I'm going to go through it again with you. Thank you so much, Jazaro. If I have a point, this is the point S, and let's say this is the point T, right? The bearing of T from S, right, is going to be the angle between, so you see the word from S, right? Because it says from S, that's where I'm putting my north line to begin with, right? So my north line is going at S because that's my starting point. It's from S. So the bearing of T from S, let me label this as my north line, right? The bearing of T from S is going to be, it's like if you had the here, right? You're starting at the north line and then you're going towards T like this. So it's the clockwise angle. You see how it opened clockwise? So this is the bearing of T from S. So that looks like it, if it's just above 90 degrees. So this could probably be about 115 degrees. Right? The bearing of T from S is 115 degrees. Now, if I wanted to find out the bearing of S from T, remember, from tells us where we're measuring the angle from, right? That's the starting point of the angle. So my north line needs to go at T now because it's from T. So my north line is here, right? That's my north line. And the bearing of S from T is you're going to be opening, you're starting to measure from here and you're going all the way around because this is a clockwise direction and then you're coming to meet S over here. Right? So therefore, the bearing of S from T is this angle on the outside here. Right? You saw it when I opened it. So now to find out what this angle is, what I will do is I will use the principle of parallel lines. So if you have two parallel lines and you have a transversal, these two angles here, this plus this, like if this is X and this is Y, X plus Y is equal to 180 degrees. That's how come I'm saying to find out what the inside angle here is, I'll say 180 take away 115, which will give me 180 take away 115 is 65 degrees. So this angle here is 65 degrees. So therefore, I can find out what the clockwise angle around there is because I'll just say 360 take away 65, which is 295. So this angle here is 295 degrees. I got it because I said 360 take away 65. So the bearing of S of T, sorry, from S was this angle over here, this angle. This is the angle, right? It's between the north line at S because it's from S, right? and the line that connects S to T. So that's this angle here, which is 115 degrees. And then the bearing of from T is the north line here. So that's this angle on the outside. All right, so that gives me, this is 295. We're gonna do one more, guys, before I leave today. So let's say I have a point, this is the point P, and this is the point Q. Or even, let me do this a little differently because I did one like that already. Let's say I have the point, so here is P and here is Q, right? If I want to find out the bearing of Q from P, right? So if I'm looking at the bearing of Q from P, because I say from P, because it's from P, it means my north line has to go at P, right? So it's here. This is where my north line would go. All right. Now the angle, the bearing is going to be the angle is the clockwise angle from the north line at P to Q. So you see the direction, right? Clockwise, right? Anti-clockwise would be this way, like this, right? So it'll be that tiny angle there. But clockwise is going to be from left to right. So you're starting at N, right? You're starting at the north line at P and you're measuring the angle around it. So you're going around to here. So therefore, the bearing of Q from P is this angle around here. That's the angle. That's the bearing of Q from P. So this looks like more than 270, right? So let's say this is 290 degrees, right? So the bearing of Q from P is 290 degrees. And if I wanted now to find out what is the bearing, if I wanted to find out what is the bearing of P from Q, the bearing of P from Q will be, well, if it's from Q, the north line has to go at Q. So let's put that in first. So my north line goes at Q, right? Let me label it. So that's my north line. Now the bearing of P from Q, it's the clockwise angle. So you're starting at the north line and you're opening out to where you meet P. All right. So therefore the angle is the clockwise angle. So the bearing of P from Q is going to be this angle. Okay. Now to find out what this angle is, I can first find out what this angle here is because these are angles around a point. So if this is 290, 360 take away 290, 360 take away 290, 70 degrees. So this angle here is 70 degrees. And therefore, this angle will be 180 minus 70, which is 110 degrees. So the bearing of P from Q is 110 degrees. All right, guys. So that is basically everything that you need to know for the trig question. There's one more thing, actually, sorry, which is the area formula. The area formula is given to you in your list of formulae. So to find the area of a general triangle is base times height divided by 2. But when you have a non-right angle triangle, or well, it doesn't have to be a right angle, sorry. If you don't have the base and the height of the triangle and you need to find the area of it, there's a formula for that as well. And it is given to you in your list of formulae, but I'm going to write it here as well. right? So let's say this is triangle A, B, C, right? And this would be side A, this will be side B, and this is side C. And let's say I have the included angle C. So you can find the area of a triangle. So the area of the triangle ABC. If you do not have the base and the height of the triangle, you can use this formula when given two sides and the included angle. So the formula is half of A times B multiplied by sine of C. So in order to find the area of a triangle, when you do not have the base and the height, you need two sides and an included angle. So kind of like the cosine rule, right? You would need two sides and an included angle, and the formula is half of AB by sine C. So it's kind of like the cosine, it's the same condition for the cosine rule, right? So if we go back to this question that we did with the cosine rule here, I can find the area of this triangle PQR by using that rule, right? So area is half of the two given sides, in this case is R and P, by sine of the included angle. So it will be half of R times P by sine of 54. So that would be half of R, which is 80, by P, which is 100, by the sine of 54. So you just type that in directly on your calculator, half times 80 times 100 times the sine of 54. And that would give you 3,236.1 to 1 decimal place. And because it's area, it will be 1 km squared, right? So that is it now. All right, so let's just go through. Now, I have compiled all of the trigonometry questions from 2014 to 2026 in a document, which I will post to our Google Classroom. And I will also post this recording for anybody that needs to do a little, to recap it. If you have problems with the cosine rule and the sine rule, we've also have videos on YouTube on the cosine rule and sine rule with lots of examples, right? But today's class was to really refresh your memory on all things Trigs so that we can now go through that entire, all those past paper questions on it, right? So just to recap with Trigs, with your geometry question. So now, actually, you will be able to do the full geometry question because it's based on circle theorems and trigonometry. So question 9 has to do with circle theorems and like triangles and bearings, right? Question 10 is your vectors and matrices questions, which we are going to do next week. But for this question 9, you've covered all of the circle geometry from yesterday and day before. And now today we've done this. So the next step is to do those past paper questions on Trigs. So I will send it to you, but we are going to go through it in class as well. So just to recap, Trigs, you use a SOHCAHTOA, sine, cosine, tangent for right angle triangles to find unknown sides and unknown angles. And it's very important that you label your sides correctly. The hypotenuse is always the side that is opposite the right angle, whereas the other two sides are named in reference to your angle of interest, right? So if your angle of interest, like in this one, is here, the opposite side will be opposite that angle. And then the third side will just be your adjacent. We also looked at Pythagoras' theorem, which is everybody says is that a squared plus b squared is c squared, but you need to know what a, b, and c represent. C squared is the square of the hypotenuse. So Pythagoras' theorem tells us that the square of the hypotenuse is equal to the sum of the squares of the other two sides. And you can manipulate that formula to find any of the three sides in a right angle triangle once you have two sides. So if you have the two sides and you need to find the hypotenuse, you will simply square them and add them, and then take the square roots. But if you had to find one of the other sides, like in this one, we needed to find b squared, we would have to say the hypotenuse squared minus the square of the other side, right? We looked at finding the unknown side and unknown angle using Trigs. Please remember, with SOHCAHTOA, with sine rule, and with cosine rule, if you are finding an angle, you have to use the inverse function. So that is sine inverse, cos inverse, tan inverse, once you're finding an angle. For unknown side, it's very straightforward, right? But with the angle, you have to use the inverse functions. With the cosine rule, you use the cosine rule when you have two sides and the included angle, or three sides and you need to find an angle. It is important to know that whichever variation of the rule you use, if you're using the rule, if you need to find side A, you would use the rule that starts with a squared, and that would be the corresponding angle, the cosine of that corresponding angle. Similarly, if I needed to find angle B, for instance, I will use the formula that has b squared as the beginning, because then that would use cos of b, and so on. These formulas are given to you in your list of formulae, but it is important for you to understand how to substitute the values into the formula and use it, right? So the cosine rule is pretty straightforward if you're trying to find an unknown side. The unknown angle is the part that gives students a lot of trouble, because when you do your substitution, students tend to subtract the number in front of the cosine of the angle from the other constant. You cannot do that, right? That's not algebraically correct. In this question, in this example, I made up the numbers, so I messed up the question because I made it up, but these are the correct steps, right? For the sine rule, A over sine A is equal to B over sine B is equal to C over sine C. Again, used for non-right angle triangles to find unknown sides and unknown angles. So you can find an angle if you have one angle and any two sides using the sine rule, right? Or if you want to find an unknown side, two angles on any side, right? But it should be actually, it really should be one side and the opposite angle for them, okay? One side and the opposite angle, because that's important actually. So we looked at finding an angle when you have two sides and you see you have one angle opposite one of the given sides. It must be that, because it couldn't be like an angle here. Because if it was this angle, well, then you would have to use the cosine rule if it was at B, right? Because that would be the included angle. That's not opposite any known side. And the sine rule itself, it deals with angles and their opposite sides. So it must be one side that is opposite a given angle, or vice versa, right? And again, to find an angle, you must use the inverse functions, all right? We looked at the angle of elevation and depression. The angle of elevation, think of looking up. So angle of elevation is between the horizontal and the line of sight. Similarly, if you think of depression, it's looking down. It's always both angles of elevation and depression are formed between the horizontal and the line of sight. So if you're thinking of depression, you're looking for the angle on top. If you're looking at elevation, you're looking at the angle from below, right? We looked at bearings, which uses three figures. It's important to know that if you're measuring the angle from if you're taking the bearing of a point from another point, that from tells you where to put your north line. So if you're looking at B from A, your north line goes at A. If you're looking at if you're looking at A from B, your north line goes at B. The two angles between two north lines they're parallel. They follow the rules of parallel lines and transversal. So they are supplementary angles, which means that they add up to 90 degrees, 180 degrees, right? So, and that's it. Oh, sorry. And the last thing was the formula for the area of a triangle if you don't have the base and the height. Again, all of these, except Pythagoras and bearings, is given to you in your list of formulae, but you have to know how to apply them, right? So I would suggest looking at the past paper questions that I'm going to send. I'm going to post it to the Google Classroom. Remember, we do have class tomorrow, so your first study session can be maths. Unless you have something else to do, you can start those questions and we will do it together. I'll confirm if we're having class on Friday or not. And also, guys, if you are going through your circles or any question, anything that you don't understand, please message me and let me know so I can help you. All right, guys. So that's it for today. That's it.